students, good day, and welcome to Grade 9 Mathematics. Are you excited to learn something new? I hope so. I am Christine Nerves and I will discuss the lesson for today. Today's lesson is all about Introduction to Quadratic Function. In the end of this lesson, you will be able to model real-life situations using quadratic function and represent quadratic functions using the table of values, graphs, and equations. Let us begin by understanding what is a quadratic function. A quadratic function is a second-degree polynomial that can be described by the equation of the form y is equal to ax squared plus bx plus c, or f of x is equal to ax squared plus bx plus c, where a, b, and c are real numbers and a is not equal to 0. Take note that a quadratic function is an equation in the second degree, which means the highest power of the independent variable x is equal to 2. How about a not being equal to 0? Consider the equation of a quadratic function y is equal to ax squared plus bx plus c. If the value of a will be equal to 0, it only means that there is no quadratic term. That gives us the equation y is equal to bx plus c. It is not a quadratic function, but a linear function. Quadratic function is one of the most interesting topics in mathematics. It has many applications and explains fundamental rules in solving many problems related to human activities. As we go along with the discussion, you will be able to understand that quadratic function is a useful tool in solving real-life problems and helps us with decision making. Let's start with this problem. The length of a rectangle is x plus 6 cm and its width is x plus 4 cm. Represent the area of the rectangle using a quadratic function. In this situation, we have a rectangle whose length is equal to x plus 6 cm and width is equal to x plus 4 cm. We need to represent the area of the rectangle using a quadratic function. The area of a rectangle can be obtained by getting the product of the length and width. Therefore, the solution will be area of the rectangle is equal to the product of the length, which is x plus 6, and the width, which is x plus 4. Multiplying these two binomials, we will get x squared plus 10x plus 24. This is now the area of the rectangle. But again, we need to represent the area of the rectangle using a quadratic function. Therefore, we will just change a into f of x. So the answer will be f of x is equal to x squared plus 10x plus 24. Let's try another one. The sum of two numbers is 20 and their product is a maximum. Represent the product p using a quadratic function. For this problem, we have two unknown numbers. But we know that when we add these two numbers, we get the sum of 20. Therefore, the first solution will be letting the first number as x since we do not know its value, and let the second number be equal to 20 minus x since their sum is 20. We need to represent their product using a quadratic function. The solution will be product p is equal to the first number x multiplied by the second number 20 minus x. We get 20x minus x squared. Change p to f of x, therefore the answer is f of x is equal to 20x minus x squared. Let's try this last one. The difference of two numbers is 15. Represent the sum of their squares using a quadratic function. This problem is the same as the previous one. two unknown numbers whose difference is 15. First, let the larger number be x, and the other number be equal to x minus 15, since their difference is 15. Represent the sum of their squares is written as the square of x plus the square of quantity x minus 15. The square of x is equal to x squared, and the square of x minus 15 is x squared minus 30x plus 225. Simplify by adding the like terms, we get 2x squared minus 30x plus 225. Represent as quadratic function, the answer is f of x is equal to 2x squared minus 30x plus 225. I hope you learned something from those problems. Now, let us move on to the second part of the lesson, which is the other representation of quadratic function. Quadratic functions can be represented using these three: equations, table of values, and graphs. Let us discuss each one. First is using equations. How would you know whether an equation represents a quadratic function or not? Is there any clues? Let us find out. We must recall that quadratic function is an equation in the second degree, which means the highest power of the independent variable x must be 2. Exponents of x that is lower or higher than 2 would mean that an equation is not a quadratic function. Let's try answering the following examples by identifying whether the following equations are quadratic functions or not. Y is equal to x squared plus 3x plus 4. Is this a quadratic function? Yes, this is a quadratic function because it is in the second degree. F of x is equal to 5 minus 3x squared. Is this a quadratic function? Yes, this is a quadratic function because it is in the second degree. How about this one? Y is equal to 5x minus 7. Is it a quadratic function? No, because this equation is in the first degree. Next one. F of x is equal to 3x squared minus x cubed plus 6x. Is this a quadratic function? The answer is no, because the highest power of the independent variable x in this equation is 3. Try this one. Y is equal to quantity of x plus 1 times the quantity of x minus 5. Is this a quadratic function? The answer is yes. We first simplify the equation by multiplying the two binomials. We will get x squared minus 4x minus 5. And this equation is in the second degree. So this is a quadratic function. Okay, last one. Is it a quadratic function? Y is equal to 2x times the quantity x minus 4 minus 2x squared plus 1. It is not a quadratic function. Simplify the equation, multiply 2x and x minus 4. We get 2x squared minus 8x. And then copy negative 2x squared plus 1. Simplify and combine all the like terms. In this case, 2x squared minus 2x squared is 0. Therefore, we bring down negative 8x and positive 1. So the equation is y is equal to negative 8x plus 1. It is an equation in the first degree. Is it clear now? Let's keep moving. This time, quadratic functions using table of values. How do you identify if a given table of values represents a quadratic function? To identify whether a table of values represents a quadratic function or not, we need to consider the following. First, the first difference of all x values is constant or equal. Second, the second difference of the y values are constant or equal. Given the table, first thing is to check if the first difference of all the x values are equal. We just need to subtract the x values in descending order. 3 minus 2, 2 minus 1, 1 minus 0, negative 1 minus negative 2, and negative 2 minus negative 3. We can see that all their differences is equal to 1. Next, get the second difference of the y values. We see that all their differences is equal to 2. Equal or constant second differences for y values means that the table represents a quadratic function. Next, pause the video for this part and try answering on your own. Does this table represent a quadratic function? The first difference of x values are equal. And the second difference of y values are also equal, which means this is a quadratic function. Did you get that right? Great! Last one for this part. Is this quadratic function or not? The first difference of x values are all equal. However, the first difference of y values are also equal, which means this is not a quadratic function. Take note that the table of values of a quadratic function shows that equal differences in x produce equal second differences in y. Let's proceed to the graphs of a quadratic function. The graph of a quadratic function is called a parabola that opens upward or downward. If the value of a is greater than 0, the parabola opens upward. And if the value of a is less than 0, the parabola opens downward. Tell whether the following graphs represents a quadratic function or not. Does it look like a parabola? Yes, it is a quadratic function that opens upward. How about this one? Yes, this is a parabola that opens downward. It means a is less than 0. Is this a parabola? No, this is a circle. Last one. Is this a parabola? No, this is a line. That is the fundamentals of quadratic functions. I hope you learned well today. And before we end today's lesson, These are the things you have to remember. A quadratic function is a function that can be described by the equation of the form y is equal to ax squared plus bx plus c, or f of x is equal to ax squared plus bx plus c, where a, b, and c are real numbers and a is not equal to 0. The degree of a quadratic function is 2. The table of values of a quadratic function shows that equal differences in x produce equal second differences in y. The graph of a quadratic function is called a parabola. And lastly, a parabola opens upward or downward. The parabola opens upward if a is greater than 0 and opens downward if a is less than 0. And that concludes our lesson for today. Thank you for watching.